A landscaper is planning a sprinkling system that will require pre-cut PVC pipe to be connected and placed in the ground. The trenches he will dig are to be 56 feet, 32 feet, and 24 feet in length. So the question is, what is the longest length of PVC pipe that he can use that will fit the length of each trench exactly and not require any further cutting? And how many of those pre-cut pipes will he use in each trench? So a couple of things we want to clarify is that if the pipe is too long, the landscaper cannot cut it to fit it. They all have to be the exact same length. And we also know that once we determine what the pre-cut length is, they have to be equally divided into 56, 24, and 32. Now here is a drawing that I did, a very rudimentary drawing of the sprinkler system, the 56 feet, the 24 feet, and the 32 feet. So the way we are going to solve for this is by using greatest common factor. First, we want to factor out each of the lengths of the trenches. So first, we have 56. And when we factor out 56, we get 2 cubed times 7. Now we can prove this by doing a factoring tree. First, we start out with 2 and 28. 28 then factors to 2 and 14. 14 then factors to 2 and 7. So we've then proven that 3 2's, which is 2 cubed, times 7 does equal 56. Our next pipe is, or our next trench is 32 feet. 32 factors into 2 to the 5th power. And we can prove that as well by 2 and 16. 16 factors to 2 and 8. 8 factors to 2 and 4. And 4 factors to 2 and 2. So we have 1, 2, 3, 4, 5, 2 to the 5th. Our last trench is 24 feet, and 24 factors into 2 cubed times 3. This can be proven by factoring tree 2 and 12. 12 factors to 2 and 6, and 6 factors to 2 and 3. We have 3 2's, 2 cubed, and 3. Now we're going to look for the greatest common factor. Two important keywords here, greatest, which means highest or most, and common. It's very important here that we find the factoring that's common amongst the 3 numbers that we factored out. So we have 7 was a factor, a prime factor of 56, but 7 is not included in 32 or 24, so it's not a common factor. We also have 3 here in 24, but once again it's not in 56 or 32. So now what we're left with is 2's. And we have 2 cubed, 2 to the 5th, and 2 cubed. Our answer on this for the greatest common factor is going to be 2 cubed. The reason it's not 2 to the 5th is because 2 to the 4th and 2 to the 5th aren't common to 56 and 24. The greatest number in 56 and 24 is just 2 cubed, and so those are the common numbers. At this point we just want to do the math. 2 cubed is 8, remember, because 2 times 2 is 4, and 4 times 2 is 8. So, having done that, gives us our answer. We needed to find out the length of PC pipe that will fit the length of each trench exactly. And by doing the greatest common factor work here, we've come up with 8. Now we just have to figure out how many of these 8-foot PVC pipes we have to connect together to fit inside of each one of the trenches. So if we take 56 and we divide that by an 8-foot pipe, we come up with 7. 8 times 7 is 56, and we need 7 pipes to connect together to fill the 56-foot trench. For 32, we also divide that by an 8-foot PVC pipe, and we get 4. We need a total of 4 pipes to fill the 32-foot trench, because 8 times 4 is 32. And then the 24-foot trench, once again, divide that by the 8-foot piece of pipe. And here we're going to have 3. We need 3 pipes that fill the 24-foot trench, because 8 times 3 is 24. So that's our answer. Our pipe length is going to be 8 feet. For the 56-foot trench, we need 7 pipes. For the 32-foot trench, we need 4 pipes. And for the 24-foot trench, we need 3 pipes, all connected together to fill the trench. And that is the answer.